Okay, so just notice that the next exam is 2 weeks from Wednesday, so I'm giving you lots of advance notice. So on the 13th. And I handed out my solution on one side to the homework due for today, and on the other side is the homework due on Wednesday. So let's go through the homework that was due today. So here, last week I introduced functions, and so I wanted you to exercise that. And so, this problem here, you were calculating. I think we almost did this before. You were calculating. No, we didn't. It's payroll for workers. I got the wrong one. Huh? That's this homework.
That's like the same thing to figure out.
Oh, wrong one. Sorry. Okay, better. So here we're calculating payroll, and we're going to prompt with instructions, and I said for the instructions, write that as a function, and then have a main function that calls the instruction routine. And of course, then we're going to have at the bottom as our first statement the word main. So as we learned in class last time, if we're using functions, typically we have a call to a main function, we have the definition of a main function, and we have, optionally in this case, we have one other function that we're calling. And so what I've done here is I've broken up the problem into two parts. One part is to print out the instructions, which I've incorporated in the print info function. And this is just a series of print statements. It's pretty straightforward. And then I have a main routine that is going to be doing a bunch of the work. The first thing that the main routine is going to do is it's going to call the print info function to print out the instructions. And then subsequent to that, it's going to be sort of a standard program that we've written before. It's going to prompt for the number of workers that we have, and then it's going to use a for loop to go through for the number of workers. The for loop is going to control how many times we're going to go through, prompting for the number of hours and the hourly rate, and then compute the pay. And so I have a for loop that controls that. And then I prompt for the pay, I prompt for the hours. If it's greater than 40 hours, I'm calculating the regular pay and the overtime pay and printing that out. If it's not greater than 40 hours, I'm just printing the regular pay, and I print it blank. This \n prints a new line. I could have just left that out, but if you remember, we had \t that inserts a tab. The \n inserts a new line. And so, right, and so the key here was to try to get you to see that to set up a program where you have a main program, you define main, you do the work, and here we've broken out the subtask of printing the instructions into a separate function. So when main runs, the first thing that happens is it calls the printinfo function. The execution of the main program is now suspended, and now we go up here to printinfo. We execute these 5 lines. We execute printinfo, And now we continue on the next statement after print info here and just continue on. And subsequently, when we end the program, we fall out of main, and there are no more statements executed, and that's the end of it. I understand you saying, well, this seemed like a big nuisance. Why do I have to break this up into functions? For this particular one, I just wanted you to get the mechanics of doing the functions. As we do more and more of these, you'll see it will influence the way you think about attacking problems, by breaking them up into functions, and the functions makes it very easy then to implement. Any questions on this? Oh, Nick?
What was the last print statement that you put in there?
This guy?
Yes.
It prints a blank line. So if you recall, in a print statement, if you have a \T, that prints a tab, right? And then if you had \T, that actually, and this will insert two tabs. If you wanted to print a blank line, you could print a blank line. Okay, so the simple way to print a blank line is you simply say print, open print, close print. That's going to print a blank line. If you say, and forget about the capitalization here. Word just does it, and I don't want it to. But if you were to say print \n, these two statements are equivalent. They'll print a blank line. If you were to say print this will print two blank lines. So the \n in a print statement, and you could put a \n in, I could say, if I were to say print then what that would do is it would print hello Nick, go to the next line, and then print hello Dave. So you could actually embed them in print statements if you want to print on multiple lines. Okay, let me go back to this. Any questions on this solution? Again, I handed it out. Obviously, there's a variety of ways of doing it, although you had to have the print info. I don't think there was no variation on that. Okay, and then the next problem. Here I didn't force you to do a main. I'll show to break this up into functions, but this will probably be the last time. So here you are writing a program to calculate what an investment would be after a number of years, and you're compounding where you can have different interest rates each year. So in the example, you're investing $1,000 over 2 years, and in the first year you're going to get 5%, and in the second year you're going to get 4%. What investment is that going to be? What is that going to be worth after 2 years? And so the way I attacked this is I said, okay, I'm going to set up a list called rates where I'm going to store the rates for the years. And I'm going to ask the person for what the principal amount is and then how many years they're going to be investing money in. And then based upon the number of years they're going to be investing money in, which I'm storing in years, I'm going to set up a for loop where I could have had I equal years plus 1 or 0 comma years. Either way is going to give me the right number of years, not number of times to prompt the person. And then I'm going to prompt them for an interest rate. And I think I sent out an email subsequently. So the input statement is different than the print statement in that this statement has to be one big string. You can't just intersperse this with variables. And all the values have to be of string type. So in order to make I, which is an integer, a string, I use the string function. So this is going to create one big string, but I'm able to get the impact of a variable by doing concatenation with that variable, which happens to be a number, as long as I convert the number to a string using the SDR function. And then whatever the person types in, I turn it into a float, and I store that in the variable rate. And now I ask you to validate that that rate was greater than 0 and less than 10% or 0.1. And if it wasn't, then you should say that there's an error and reprompt them for the value. They're going to re-enter the rate in. And what I did here is I'm going to append the rate to my rates list. So I'm going to take that rate and append it to the rates list. But before appending it to the rates list, what I did is I divided it by 365 because I'm doing the calculation of the interest rate compounding daily. So taking the rate, let's say they typed in 0.05 and dividing it by 365 gives me the interest rate on a daily basis. So now I'm going to have in rates the interest rate daily, which is going to be a very small number, but we're doing it 365 times. And then, okay, so, oh, I see. So this is really getting you to embed a while loop within a for loop. First, here you're doing validation, and here you're getting the actual values. And here I'm getting you to exercise having nested for loops, where the outer for loop is doing it for the number of years. Here I did it from 0 to years as opposed to 1 to years plus 1. Both are the same because all I really want to do is do it a number of times. And then I have a for loop for day going from 1 to 365. I did it to 366. And what I'm doing here is I'm taking whatever the balance is, which initially was just what the investment was, and I'm multiplying the rate. From my rates list, I'm getting the year. So I want to find out what the rate is in the first year. So year is 0, and I'm multiplying times the balance. That's giving me how much interest you're getting in that particular day, and then I'm adding it back in the balance and putting it back in the balance. So this inner loop here is computing day by day what my balance is going to be, tacking on the interest each day. But it's compounded, so I'm taking the value, I'm computing interest upon interest because I'm taking the interest and adding it to balance, and the next time through, I'm computing the interest based upon what that previous balance is, which reflects the principal amount plus whatever interest I have. So this is going to then iterate through 365 times. And then when I'm done with that, that's going to simulate getting the interest for one particular year. I fall out of this inner for loop, and I go to this for loop, and I increment year by 1. And now if I still have more years to do, I'm going to go back and now recalculate how much the investment is going to increase in the second year. And if there were 3 years, it would be the third year, and so forth and so on. And I did this I actually didn't have to do this. I could have actually done this simply, our typical way of doing print, by simply putting the variables in there. I didn't have to use string, I don't think. This worked. I did test my code, but it's different than what we had been doing before. Right. Any questions on this? Nick, you had a question?
Yeah, I didn't have the nested fours function at the end where you had the 4-year and range 0 years, and it works for me.
But you had this?
Yes.
Well, how many days did you do it for?
0 to 365.
You only did it for 1 year?
Well, within that year, that it was underneath the first range.
Wait, so you had this statement or you didn't have this statement?
Right.
Right, you did have it or you didn't?
I didn't have what you're highlighting.
So that wasn't there.
Yes.
You just had this.
Yes.
And you got the same result?
Yes.
But I don't believe you. Sir, you're not going to tell me you did that too?
I did it pretty different. I just looked up the formula for if we wanted to calculate
Future value?
Yeah, essentially. And then I just did it by year. I didn't make a list of rates.
You didn't have to,
Yeah.
right? Anik?
I did the same thing, like with the first one I didn't put it in because it's under the other form.
Oh! Is that what you did, Nick?
Yeah.
And did you have this 0 to years? Because then you have to have the right index here.
Yeah, I like that one.
Oh, I see what you did. Oh, I get it.
Yeah,
So you didn't need to,
do another form.
but this screwed up the whole point of my assignment. So, I'm just kidding. So you didn't have to have the rates list.
No.
You're breaking my heart.
I personally didn't even have a for statement. I just had a while statement.
You could use while also.
Yeah.
Okay.
And then I just had like 1 plus rate divided by 365 to the exponent of 365.
Right. Okay. Jordan?
Yeah,
Uh,
that's the for loop. I don't really have one of those in there at all.
You don't need it. It's been made clear to me by some of my former favorite students. So,
This with the interest rate I did, but like, I kind of just did it based off the interest rate instead of based off the years. So I made the list, and then it said, oh, you have an interest rate for every year. So I said, okay, then that can basically be used for the for statement. So I just did 1 plus x over 365 to the power of 365.
yeah. So you did the future value function.
Yeah.
Okay, I'm only kidding you guys. So I understand what you did, Nick, now. So you didn't, if you didn't need this for statement because you could have used it within here.
Because it was already in that.
Yes, right. And you didn't even have a rates list because you could have just gotten the rate and used that rate.
Right.
Okay. I don't know, I'm talking through this. Did everybody get this? So another solution, I guess better than mine, pains me to say, is you don't, does everybody get this? I guess I made this more complicated than it had to be. You could have simply had this. You could have done this. Okay, this is one simpler way of doing it. You didn't actually need to have a rates list. You could have just done this by, and you did need to have this. And you simply could have had here 1 divided by, no, strike that, rate divided by 365. And so you didn't need to have a list. You could have just prompted for the rate and then gone through and iterated day by day to calculate the compounded rate this way. Does everybody get it? There was no reason, because you're in this loop going through the number of years, you could have used that for loop to then, after you've gotten the rate, to then use that in this calculation. That's one way to do it. The second way to do it is obviously, not obviously, so people remember in their finance class, what I'm really computing here is future value, what an investment will be worth in the future based upon an interest rate. And I don't remember, so Anik, what's the formula for that? So it's BAL is going to be equal to, I guess what? It's going to be equal to,
Same.
But don't you have to raise it to,
Just raise it to the 365th power, so it'd be asterisk to 365.
so if you raise it to 360, the power of 365, then you wouldn't have this. So in a recompute, it would calculate what the value of that investment's going to be,
I
right?
did something else. I
Really?
made another for statement that's how you had it. Like I had the 4 days in range 1 till 366, and then the balance equals balance plus balance times.
Oh, you did, but you didn't do this.
No.
Okay, so you did the one part.
Yeah.
Yeah. Right. So I had done that before. Right. You got rid of. So this was another way. So if you remember in your finance class, you don't have to go through the iteration. This does the same thing. This compounds daily what that value of the investment's going to be.
It has to be the 1 plus rate, though.
I'm sorry.
1 plus rate over 365. That's the formula.
That one.
Yeah.
Oh, right. Because otherwise you're just doing the interest. Right. Okay. I think we'd get that much conversation out of that, but that was fun. Okay. So, thank you. So, let's start some new stuff. I went over that. Okay, so here we go, guys. This is new stuff. You got to concentrate on this. So, suppose what I want to do is I want to write a function. So I'm going back to functions. So I'm going to write a program that's the main function. It's going to call a function called qubit. And in the main function, we're going to ask the user for a number to be cubed, raised to the 3rd power. And the main function, what I want to do is I want that main function to then take that value that it got and pass that to qubit to actually do the calculation for the cube. Then the qubit function will calculate the cube and print out the results. So here we're going to learn now a new facility within using functions, and that is the facility to get a value from the function that is from whoever is calling it to actually do the calculation. Can you guys see this in the back? If you go to Blackboard, I've downloaded I've put the slides up. So if you want to download the slides, you'll be these are the slides that are there. And I should be able to make this bigger. Okay. So here's the deal, guys. So we have now a main, we're executing main, and we have a main function, and the main function is going to prompt the user to say, enter a number to be cubed, and we're going to take that number and put it in the variable n. You guys got to concentrate on this. It's a little tricky. We now want to call another function to take that value that the person typed in, and we want that function to cube it, take it to the 3rd power, and then print out the value. The question is how do I know how I can invoke a function. I simply can give the function a name. How do I, in addition to invoking it, give it a value to work on and give a result? The way you do that is after you put the name of the function in parentheses. Before we just had open and close parentheses. Now, within the parentheses, you put the name of the variable that you want to pass to that function and have that function work on. And since in main I put in the value that the person typed in into the variable num, when I call the function qubit, I now put in parentheses the name of that variable, and that variable will be passed to the qubit function to now to be worked on. When I define the qubit function, I now have to add in between the parentheses the name of a variable. The name of this variable here can be anything that I want. Point number 1. I called it Val. I could have called it David, Seton Hall, anything in the world. It's just a variable. The way this works is when if when we prompted the user typed in 5, so num is equal to 5. When the qubit function is called, num has the value of 5. Qubit's called. A variable called val will be created, and it will be initialized to 5, because that's the value of the variable num. Whatever value this variable has, this variable will be created and set equal to it. So when qubit runs, it assumes the value that the variable num has. Let's go through this. You got it? Now the qubit function runs, and val has a value. Val has a value. It's 5, and we simply execute the print statement. It's a simple function, and it says print the value of val. So it's going to say print the value if 5 qubit, and it's simply going to take these values. It's going to take 5 and give you 5 times 125. The function qubit now stops because it executed its one and only statement. It halts. Everybody ready? The variable val now gets destroyed. It goes away. It's as if it never occurred. The variable val only exists while the function qubit is running. Once the function qubit has stopped, that variable val goes away. Point number 1. Point number 2, the value, you might say, well, does that kill the variable num in main? The answer is no. Those are 2 independent variables. So when this program, when qubit gets called in memory, there's a spot in memory that holds the value of val, which is 5, and also holds the value of num, which is 5 too. They're 2 completely different spots in memory. After qubit stops running, the variable val in memory is erased. It's gone. It no longer exists. This variable num still exists, and if I wanted to do something else with num after I called qubit, I could. In this case, nothing is done, and I simply fall out of main, and now the program stops. So with all this hand waving, what's the whole point of my hand waving? The whole point of the hand waving is we're dealing with functions. We want to call one function, wants to call another function, and in a lot of cases we want to give that function that's being called a value to work on. We do that by putting in parentheses the variable. Now, it didn't even have to be a variable. I could have typed in the constant 5 there. It didn't really make any difference. But when the function runs, it now creates a variable and initializes it to a value. It initializes it to the value of the variable here, and then continues on working, and then after that function has died, that variable goes away. It's as if, again, it's sort of apportioning responsibility. So suppose I assign, in class, we're taking a problem, we're breaking it apart, and I give, let's pick on Nick again, and I say, okay, Nick, you're going to write this part of this program that's going to cube a number, and Nick says, fine, tell me what the number is. I'm going to tell you, I'm going to pass it to you. I'm going to pass it, I'm going to call you Nick, I'm going to tell you what that number is. And Nick's going to take that number, and in his head, he's going to do the calculation, and he's going to print it out, and then after he's done, he said, I'm done, and that value that I passed him, it goes away from Nick. It's as if it was never there. Okay? And this is how you can pass values to functions. These are parameters. We're used to doing this, by the way, right? We do this all the time. Because when we call, if I were to have a variable x is equal to a, b, c, d, and I wanted to find out the length of x, what do? I would type len open x, right? I would call the function len and pass it a value. I'm passing x, which has the value a, b, c, d. The function len, which is built into Python, then takes the value of x, does something, calculates the number of characters in it, and returns 4. And then when I passed it, note that the variable x still exists. It's still mine. It's still there in memory. But however the function len did its operation, I don't really care. I simply gave it a value. It was in the variable x. It did its thing. It gave me a result. It went away. And whatever remnants, however it did its processing to calculate the number of characters, that's gone. So we're used to this. We're used to dealing with functions, and we're used to dealing with functions that take parameters. All I'm introducing now is that we're now in the business of writing our own functions, And now I'm teaching you the mechanics of how you can get, when you're writing a function, a value. That's it. Full stop at this point. This is how you get the value. You now have created a variable. That variable has a value. And you use that variable as you've used before with other variables. There's nothing really special about it.
And we can use it like for any power, right?
Say that again?
We can use it for any power, like not just.
Sure, I could have add val times val times val times val. There's no restriction. It's a regular variable. Once I get in here, it's a variable. I can do it. There's no difference, Nimrod, from that variable than the variables you've created in your programs up to date. It's exactly the same, except how it gets created, and it gets initialized for you. There's a value set to it. It's initialized to whatever num is. That's special or different than what we've done before. And what's very different is that variable goes away once the function has died. It's as if, doing the analogy to giving a person a problem to solve. Okay, so we're taking a big problem and I'm saying, you do this. And I'm saying, Nimrod, I don't care how you do it. You can create as many variables as you want. I don't care. But once you give me an answer, Nimrod goes away and everything she's done goes away. All I care about is the answer.
So if you do like like in the last part, you said star val, like how we do the raised to part, would that work as well?
Say again. Let me type that. You said?
Star val.
Well, this would
Yeah,
take val to the val. So if it was 5, it would take 5.
times 5. Like would that?
5 to the 5th power.
Yes.
Yeah.
Okay.
This is how you do exponentiation 2 stars.
Got it.
Okay, so let's continue. Okay, so this is just in the notes this is what I was waving my hands about in terms of how this works. Okay, ready? Everybody got that? This is mechanical. There's not like huge conceptual understanding here. This is not like understanding how to use a for loop or a while loop or that stuff. It's just, how do I get a value to a function? That's step one. Okay, so here I have another program. It's really not that much different. I have main, and I have a main function. I create a variable called xyz1, and I set it equal to 2. And I have a variable qqq2 is equal to 4. I've made up stupid-sounding variables just to show you that the variables have no meaning. And now I want to call a function called receive that will print out these two values. So this is the same as qubit. Instead of cubing the number, I'm simply printing out the values. But the difference here is now I'm not passing one value as an argument. I have two arguments here. I have xyz1 and qqq2. Two parameters I want to pass to receive to do something. The concept is the same. I have the function called receive, and I've defined receive up here. And here I have two variables separated by a comma. Each of the variables have a value. So in this particular case, when main executes and it calls receive, note here that receive is going to create a variable called any, and what is it going to initialize any to in terms of the value? It's going to initialize it to the value stored at xyz1. And then it's going to create a variable called any2, and it's going to initialize it to the value of the variable qqq2. So if you have a function where you need to work on two different values, you put the list of variables, and I could have just had a number here, I could have had a constant. And in the defining function, you have the same number of variables. The names of the variables do not have to be the same. They can be. If you wanted to, I could have had xyz1 and qqq2 here. I could have had those two variable names here, and it wouldn't have bothered Python. The names could be the same if I wanted to. It's a matter of choice in terms of what you're doing with the function. So when the receive function is called, it creates two variables, it initializes, and it creates two variables, any1 and any2. It initializes both of those to the values, and it does this in the order here. So the order these variables pair up, the first variable here is, the value of any one is set to the value of the first variable here, and the value of any two is set to the second variable here. And then 81 and 82 are simply variables within the receive function. I'm simply printing them out. The receive function has nothing else to do. It goes away. The variables any one and any two die. They go away as if they never existed. And I come back to my main program. There's nothing else to do after the main program, and the program then dies. Note that main is also a function, and therefore the variables x, y, z, 1 and q, q, q2 are variables that get created when main gets called. They don't have any, when main gets called, they don't have any values. I have to explicitly assign them values. After main completes, those two variables go away also. So here I've just extended from having one argument to having two arguments. The idea is exactly the same. And we've used functions with two arguments. So I've written out here in a list, I think I've gone through this verbally, about what happens step by step here. You can look at this later if you're confused. I'm going step by step. What happens when this program runs in terms of variable creation and having values, having the variables assigned a value, and then the fact they get destroyed and the order in which this happens. Why don't you guys try this as an exercise? So now why don't you go and try to do the following. Write a program that prompts the user for two numbers and returns their product. So you're going to have a main function that's going to prompt the user for the numbers, pass both of those values to the function multit, and then in the function multit, the multit function is going to multiply the two numbers together and then print out the result. So you're going to have two functions, main and multit is going to be called by main. Okay, so I'm going to write a main routine. I'm going to write a multit routine. Whenever I'm writing a program nowadays, first thing I'm going to do is I'm going to call the bottom of my program. I'm going to have main. I'm going to have the call of main, and then somewhere above I'm going to define main. And main is going to prompt the user for a value, and I'm going to put that in the variable called num1. And it's going to prompt the user for another value. I could have just done and now the two values in variables num1 and num2, and now I want to call the function multit, which is going to multiply them together and print them out, the result. So I'm going to say multit. And I want to pass it to two variables that I'm working on that I've just got the value for, num1 and num2. So now I've called multit, passing it the values that the variables num1 and num2 have. And now I'm going to define multit, and it's going to take two variables. And again, these variable names are whatever I want. So I could call it val1 and val2. I could have called it x and y. It wouldn't have made any difference. And so multit will right. Multit will take those two values and in a string print them out. So this wasn't very much different than qubit, except I'm actually just doing it, multiplying as opposed to raising it to the third power. Again, these variables could have been anything. This could have been x and y. And then I would have had, instead of val1, I could have had x and y. It doesn't care. Could have been x times y. It could have been num1 and num2. I don't want to do that yet because that'll confuse you. Okay, is everybody okay with this? What would have happened if I would have said, what if I would have had in the function multit a print statement where I printed out the value of the variable num1? Surya?
You get an error because in your function that you're not defining.
Exactly. Okay, so everybody's got to be clear on that. Very good. So these functions are really, by design, and this is a feature, they're sort of isolated from everything else. They live in their own world. And a function, variables, okay, the variables can be, here we're defining x and y. We could define other variables here. I'll do that in a minute. But the variable num1 has not been defined. It doesn't exist within multit, even though it exists within main. Nick's got his variables. I got my variables. Unless I pass it to him, for now, he can't see my variables. They're mine. That's a good thing.
What would happen if we named the variables the same in both the multit and the
Okay.
function?
Good. So if I would have said,
You name those num1, num2.
so now, how about this? What would happen if I would have done this? It should work. Not it should work, it will work. But let's be clear here. When multit, I called it multit again. Yeah, multit runs, it creates its own variables called num1 and num2. They are initialized to the variables num1 and num2 in main, but outside of it, they have no impact on the value of the variables num1 and num2 in main. So, Panos, if I would have said num1 here at the end is equal to 47, that will not give an error. That's fine. Num1 exists within multit, and I have every right to assign it a value. It's fine with that. But after multit runs, if I were to say print num1, let's suppose when I ran this, num1 I had set equal to 3. I run the function, I set num1 equal to 47, and now I come back, what's num1 equal to? 3. The fact I gave this variable the same name as in here is of no significance.
So you're right in saying that anything you put in that first function are essentially just placeholders. They're just a way to make sure that the code works within that function.
Correct. Spoiler alert, in subsequent lectures I will show you a way of sharing variables, but for now, and typically it's a bad idea. But for now, and what the discipline you should have is, function has its own variables it works on, it doesn't share its variables with other people. This is the opposite of trying to teach an infant. This is no sharing. I want my variables, no one else can have my variables. You can tell me what value to start my variables with. Okay? And note here, it is perfectly legal for me to say num3 is equal to 13. It is fine for a function to create its own additional variables in addition to the ones that got passed to it. You can create as many variables as you want within a function. That's okay. You might need them to do whatever calculations you want. That's fine. But num3 will not be available to any other function. And when the multit function dies, num3 goes away. And you might ask, well, why would you want to do this? You would want to do this because for the same reasons you've created variables in every other program you've had, you need a place where to store things temporarily. So if you were doing a for loop and you need to do for I in range 0 to 15, you need to create a variable I, right? Well, that variable I would have been created in that function, and it goes away after it's done. Let's take a look at this code. So I have main, I've defined a main function, I have a variable arg1, arg2, arg3, I have a variable called balance, which is equal to 500. And then I call a function called my function, passing it forget about the case here, crap. So annoying. So I have these three variables. Boy, I'm not doing well, am I? Okay, so I have these three variables, arg1, arg2, arg3, and I call my function, and I pass arg1, arg2, arg3, and my function has three parameters, param1, param2, param3, so param1 is going to be initialized to 4 because that's what arg1 is, param2 is going to be initialized to 5, and a param3 is going to be initialized to 7 because that's what those variables are. And note here that I now create a variable called balance in my function and set it equal to 1,000. Does this, when this function ends, when my function ends, what's going to be the value of the function balance? What's going to be the value of the variable balance after I return from function? When at this point here, after function ends, my function ends, and I return from my function, I'm doing more stuff, I have this variable balance, what's going to be its value? It's going to be 500. Everybody should be clear on that. Because, yeah, I created a variable called balance here, that's fine, but that variable balance has nothing to do with this variable balance. They're in two completely separate worlds. It's fine that the same variable name exists within two completely separate functions. Changing the value in one function does not impact the value in the other place. It's as if they were two different variable names. Dan, you look puzzled. You're good with this? It's just, this is the way the rules are. It makes a lot of sense. What we're really trying to do in writing functions is write code that does a particular function and doesn't screw up anything else, and it returns a value. We'll show you it does something, and once it does that thing, it goes away, and it has no other side effect. Okay, so last idea with this, okay, this is, now we've had experience here when we used, let's say, the len function, that the len function doesn't print out a value, right? When I call, I mean, if I were to say y is equal to len of x here, where x was ABC, then len does something. It computes the number of characters. Okay, everybody listen. I know it's late in the lecture, but this is like a big thing in using functions. The len function does something. It calculates the number of characters, and it returns that value. In this case, I take the value that len returns and I assign it to variable y, so now y is equal to 4. So len does a calculation, counts the number of characters, and it returns back that result to me. It doesn't print it out. The len function doesn't print anything else. It simply says, oh, I'll count the number of characters in the string you passed me, and I'm going to send it back to you. That result I'm going to send back to you. And you can do with it whatever you like. In this particular case, I set it equal to the variable y. In other cases, I could print it out. So the key here is that the function does some calculation and then returns a value. How do we write a function now? I've shown you how we can create a function. In this particular case, it does some calculations. It could take values that we pass to it, and it prints it out. But now how do we create a function that passes back a value, the result of some calculation? So how could I take the qubit function that I started off with? So this qubit function that we started off with, the qubit function simply printed things out, but I don't want it to print out. I want you to do the calculation and give me back that result, and I'll figure out what I want to do with it. Okay, so if you want to write a function that returns a value, just make this a little bigger. We just have to add one more statement. Well, let's focus now on the qubit function. So the qubit function before printed something out. Now what I've done, instead of printing something out, is I perform the cubing of the variable. I take the variable, multiply it 3 times, and I set it equal to a variable. I'm allowed to do that. I create a variable in my function, cube value, and I've set it equal to the cube of the value. Here's a statement we haven't seen before. If we want to have a function return a value, we then have the word return and then that variable with the value we want to return. What that's now going to do is, wherever qubit is called, it is going to return to the place where qubit was called the value of cube value. If let's focus here on now where we call qubit. This is different. Before we simply called qubit, we simply said qubit, we said qubit and num, and it printed out the values. Now you'll notice that qubit, in addition to passing the value num, has now appears on the right-hand side of an assignment statement. And so this gets called, qubit's called, we now calculate the cube, and then the last statement in qubit says return that value. That gets now placed here. So whatever that cube value is now replaces the call to the qubit, and now it is used to set the variable cube num to a value. This is exactly the same as when we did len, y is equal to len of x. We called len, we passed it a value, it returned a value, the number of characters, and we set it equal to y. We're doing the same thing. We're calling a function instead of calling len, we're calling qubit, and we're passing a number instead of x, and qubit's going to do something. It's going to cube the number. It's going to send us back that result, and then we're putting that in a variable. So by having the word return and a value in my function, I can now have a function that does some calculation and returns back that result. And the place where the function that calls consumes that by either, in this particular case, initializing it in a variable. I could have, if I wanted to, instead of that, I could have said print I could have used that in a print statement if I didn't want to assign it a variable. We've done that before. We've used functions within print statements and just have it print out the result because qubit returns a value and I want it returned and I want it printed out. So I can assign the result of qubit to a variable or I can print it out. Again, just think back to how you use len and any other functions. Even thinking back to what you in your Excel days when you called functions within Excel. The function does something, it returns a value, I take that value, and I do with it what I want. And all we've extended, the only thing we've done differently here is we've introduced a statement called return that gets put in the function to return the value. Any questions on that? Okay, why don't you guys try one now? So write a program that prompts the user for a number and prints out the absolute value of that number. I know that the absolute value function exists, but you're going to write your own absolute value function. You're not going to use the one that's built in. So you're going to write a function called main, which is going to prompt the user for the value, for the number, and pass that value to the function. You're going to write a function called find ABS2 that takes that value, determines the absolute value, and returns that value back to main. The main function will then take that value, the absolute value of that number, and print out the result. So again, you're going to have a main function, and you're going to have a find ABS2 function. The ABS2 function is going to find what the absolute value is, return it back to, it's not going to print it out, it's going to return it back to main, and then main's going to get that value, and it's going to print it out. You have to have, ways.
statement is computed.
Yeah, let me go back to this. Okay. So if we were to write this, so just show you the difference. If we were to write this not returning a value, but by simply having, should be ABS 2. Well, okay, this is ABS 1. Fine, I get it. So if I were to write this to print out a value, I would have main, in my main function, I'd prompt for a value, put it in num, call the function ABS1 passing num. Num, in my particular function, I have a variable val, so val is going to assume the value of none. I'm testing to see if it's greater than or equal to 0. If it is, I'll set the variable ABS val to val. If it's not, I'm going to take the negative of val minus val, so this is going to compute the absolute value. And then I'm going to print out the absolute value. So the absolute value of val is this. Note that I'm doing this in ABS1. Okay, this is not what I asked you to do, but I'm just showing you the difference here. And then that exits find ABS1, and then the program ends. That exact same code, to translate that to have find ABS1 return a value, now all I need to do is now, instead of printing it out, my code is exactly the same, except now instead of here, instead of having a print statement, I have the word return ABS num. And in my call here, I have find ABS2. And note now, instead of just calling it without assigning it to any variable, now it appears on the right-hand side of an assignment statement. And I assign it to the variable ABS val. So now ABS val is going to be the value that this returned. And now I simply print out ABS val. So here, to write a function that returns a value, the only difference is that you have a return statement. And after the return statement is either a variable or a number or an expression of what you want to return. That value gets returned as the last step in what find ABS does, ABS2 does, and in this case it returns back here. So now whatever value find ABS2 returns is assigned to ABS val, and then it gets printed out. So that's how we have to do to return to actually have functions return a value. It is not required that the last statement is always a return ABS. It's a better way of writing programs. But if I wanted to, I could have said actually here, I could have had multiple return statements, and this could have simply been return num, and this could have been return minus num. And that would have given me the same, I wouldn't have needed to have this return statement. So there's not a requirement that the return statement only appear once as the last statement. It could appear as many times as you want. It's typically a better idea if you only have it as the last statement at the end, but it's not, you don't need the equal here. Sorry. Okay. I'm not sure why it's not. Okay. Any questions on this? Nick?
So you couldn't have done it with the absolute value if, like, you didn't have that stipulation in there. That's how you couldn't, right?
I'm not following.
Like you said explicitly not to use the absolute.
Yes.
But if you did, would it just give you the same thing?
Oh, yeah, you could have, okay, you could have. you could have, to cheat, sort of, you could have said, okay, so for some reason, you could have had ABS of num there. And that, yes. Yeah, okay. The point is to exercise using the return statement. Any other questions? So everybody got the homework assignment? It's on the back of the code, if you can get it. So you'll be exercising returning values from functions. I realize it's somewhat confusing, and it seems like, boy, this is more work than it's worth. But you have to do a little investment in using it first, and then you'll see why it's better after you get some experience with it. So, okay, that's it for today.